In this lecture, I am going to discuss about the state transition matrix. So, in the previous lecture, I have already discussed about the state equations and output equations of in the state variable models. So, in this lecture, I am going to discuss about the relationship between the state equations and the transfer function. So, in the previous lecture, I have already discussed these equations. I have already discussed this equation, state equation and output equation. So, state equation is x dot t is equal to ax t plus but and y is equal to cx t plus dut. This is the output equation or measurement equation. So, for finding the transfer function of this state equation, so basically what is the transfer function? Transfer function is the ratio of Laplace transform of output to the Laplace transform of input by taking all initial conditions 0. So, I have discussed this state space model in which I have told you that the inputs are, input in the state space model is u t and output is y t. So, what we have to do in this we have to do for getting the transfer function, we have to find the ratio of this output to the input, means we have to find ys by us, where ut is the input and yt is the output. So, these are the state equations, x dot t is equal to ax t plus but. So, I will take the Laplace transform of this equation and Laplace transform of this equation. Say this is equation 1 and this is equation 2. So, if I differentiate, if I take the Laplace transform of derivative of any variable, so as we know that if xt is a signal whose Laplace transform is xs, then the Laplace transform of x dot t will be dxs by, will be sxs. So, what will be that Laplace transform of x dot? X dot Laplace transform of x dot will be sxs. Now, Laplace, I am taking the Laplace transform of this equation 1. So, what will be the Laplace transform? X dot Laplace transform of x dot is sxs, Laplace transform of axt is axs and Laplace transform of but is bus. So, we will get sxs is equal to axs plus bus. So, I can write this equation like this, sxs minus axs is equal to bus, because A is the matrix. So, if I want to subtract this from this, s minus a, s is the coefficient, a is the matrix, or you can say the variable. So, we have to convert this sxs into the matrix form. So, what will I do? I will multiply with the identity matrix. After multiplying by the identity matrix, this factor will become si minus a xs is equal to bus. So, I will get here xs is equal to s minus a inverse bus. So, again I will take the Laplace transform of this equation for equation 2. So, what will I get? I will get ys is equal to cxs plus dus, and ys will be equal to, I am going to replace this xs by this value. Xs is equal to si minus a inverse bus. So, it will become ys is equal to c si minus a inverse bus plus dus. So, what I want? I want to get the ratio of ys and us, which will give the information about the transfer function of the system. So, ys by us will be equal to, you can take common us from this equation. So, I will get here c si minus a inverse b plus d into us. So, ys by us will be equal to c si minus a inverse b plus d. So, this is the transfer function of the state space model. Let us take an example. In this, a, b and c is given and we have to find the transfer function of the system or state space model. So, the formula for this is for transfer function is c si minus a inverse b plus d. So, first we have to find the si minus a inverse. So what is the value of Si minus A? S is S into I is to A, because A is 2 cross 2 matrix, so I will also be 2 cross 2. So I can write here S 1 0 0 1 minus A is minus 2 0 1 minus 3. So Si minus A will be equal to S plus 2 minus 1 0 S plus 3. Now for finding the inverse of any matrix, so A inverse is nothing but adjoint A upon mod A. For finding the inverse of any matrix, we have to find the mod of that and adjoint of that. So this is so Si minus A inverse will be equal to adjoint Si minus A upon mod of Si minus A. So after finding the value of adjoint, we will get S plus 3 0 minus 1 S plus 3, and what will be the value of mod of Si minus A? Si minus A we can find like this. Mod of Si minus A will give S plus 2 into S plus 3. Now what will be the value of C Si minus A inverse B? This is the simple multiplication. C is 1 comma 1 1 1. Si minus A inverse is S plus 3 minus 1 0 S plus 2 divided by S plus 2 into S plus 3 multiplied by B is 0 comma 1. So this will give Si minus A inverse B. D is already 0 because D is not given, so we can consider here D is equal to 0. So this will give 1 by S plus 2. This is the transfer function of the given model or given system. So in this way we can find the transfer function of the state space model, but you have to remember the formula for this transfer function. One more thing, you should know what is A, what is B, what is C and what is D. If D is not given, then it will be considered as 0. Otherwise if D is given, then you will include in this equation. Now coming to the next topic, that is a solution of a state equation. So as I have already told you that this is the state equation x dot t is equal to axt plus but. So this this is the time variant system, and the equation can be characterized into two categories. First is homogeneous state equation and second is non-homogeneous state equation. So if I am considering this as a homogeneous, this equation is said to be homogeneous if A is a constant matrix and U is 0, or you can say this will be homogeneous only when if x dot t is equal to axt, means input is considered as 0, or you can say this is the free response of the system. But in case of non-homogeneous equation, this equation will be as it is as written here, or you can say this will be equal to x dot t is equal to axt plus but. What is the difference between homogeneous and non-homogeneous equations? In homogeneous equation we are considering ut as a 0, but in case of non-homogeneous equation we are considering ut as a non-zero vector. Now coming to the solution of this homogeneous state equation. So I have already told you that in case of homogeneous equation I am considering only xt and considering ut as a 0, or I am considering that ut is not present. So this equation will become x dot t is equal to axt. So for finding the solution of this, I will again take the Laplace transform. So after taking the Laplace transform, we can write like, I am not considering here initial condition 0, so I am including this initial condition. So as you know that if I am taking the Laplace transform of derivative of any variable, this will be sxs minus x0. Now sxs minus x0 is equal to a into xs. So again you can write this si minus a xs is equal to x0. So xs will be equal to si minus a inverse into x0. So xs will be equal to, you can say phi, I am replacing this si minus a inverse by another variable, that is phi s. So xs is equal to phi s into x0, where phi s is equal to si minus a inverse. You can expand this using this formula, or if you don't want to expand, there is no need to expand, there is no need of expandation. Now, what will be the value of xt? So, I have taken here xs is equal to phi s into x0. So, for getting this, if I want solution of any equation, this is the differential equation, x dot t is equal to axt. So, if I want to find the solution of any equation, it means I want the value of that variable. So, here we have to find the value of xt. So, for finding the value of xt, we have to take the inverse Laplace of this equation 1. So, if I take the inverse Laplace of this equation, this xs will become xt and this phi s will become phi t and x0 will be as it is. So, you can write here xt is equal to phi t into x0. Now, what will be the value of phi t? From where we will define the phi t. Phi t is nothing but phi t is nothing but I plus at plus a square t square plus a square t square by factorial 2. From where we got this? We got from here si minus a inverse is defined like this. So, for getting the value of phi s, we have expand this equation like this. So, this is phi s is equal to I by s plus a by s square plus a square by s cube and so on. So, if I take the Laplace inverse of this, then I will get phi t is equal to I by s. I by s will be 1 because inverse Laplace of 1 by s is unit step signal. So, I am not considering here a unit step signal, I am writing here 1. And again, you can see a by s square. A by s square will give at. Again, a square by s cube will give a square t square by a square t square, and so on we will get. So, this is nothing but 1 plus at plus a square t square. This is nothing but e की power at, e raised to at. So, this is nothing but phi t. So, phi t is equal to e की power at, where phi t is defined as an exponential signal and phi t is also known as if phi t is known, it is possible to transit from x0 to xt because phi t is the state transition matrix. So, if phi t is known, it means e की power at is known, we can transit from x0 to xt. Now, what is a state transition matrix? A state transition matrix is defined as the transition of states from initial time t is equal to 0 to any time t or final time tf when the inputs are 0. So, it is the response due to the initial vector x0 and it is dependent on the initial state vector and not the input vectors. It is called as zero input response since input is 0. So, when we have find this state transition matrix, we have considered this, we have considered ut is equal to 0, or you can say we have considered that ut is equal to 0 or without input, we have find the state transition matrix from the state equations. It is also known as the free response of the system because the response is excited by the initial conditions only. We are here. I am not considering the input signals. So, this response is dependent only on the initial conditions of the systems. Now, coming to the properties of this state transition matrix. This is not machine. This is matrix. Matrix. So, first property is phi 0 is equal to I, because we know that phi t is equal to e की power at. So, if I want to know phi 0, what will I get? E की power 0 is equal to 1, because we want to represent this in a matrix form. So, I can write here phi 0 is equal to I. Next property is phi inverse t is equal to phi minus t. If I take the inverse of this, e की power at minus inverse of this. So, what can I write? And if I want to know power minus at, what will be the value of phi minus t? If I replace this, e की power a minus t, then we will also get here e minus at. It means phi inverse t is equal to phi minus t. You can see here. Next property is phi minus t is equal to e की power minus r. Next is phi t2 minus t1 is into phi t1 minus t naught is phi t2 minus t1. So you can see here, you can write phi t2 minus t1 is equal to e की power a t2 minus t1 into e की power a t1 minus t naught. So what will I get? This will be cancelled out and you will get here e की power a t2 minus t naught. Next property is phi t की power m is equal to phi mt, where m is a positive integer. So you can write, if you are writing this phi t की power m e की power a t की power m, this will give e power a m t. So we can write here e power a m t. So you will get here e power a t is equal to phi t. So e power a m t will be phi m t. Now coming to the solution of non-homogeneous state equation. So in the homogeneous state equation we have considered ut is equal to 0, but in case of non-homogeneous state equations we will consider ut and it will be counted in the state equation. So x dot t is equal to axt plus but. Again we will take the Laplace transform of this equation. After taking the Laplace transform, and we are also considering the initial values, initial conditions. I am not ignoring this x0 as I am not ignoring this x0 or I am not considering it as a 0. So it will be equal to sxs minus x0 is equal to axs plus bus. So I am transferring this to the left side axis. So it will become si minus axs is equal to x0 plus bus. So xs will be equal to si minus a inverse x0 plus si minus a inverse into bus. So if I take the purpose of finding the solution is that to get the value of xt, because the differential equation is this, the state equation is. So again we have to take the inverse Laplace of this equation. If I take the inverse Laplace, then I will get xt is equal to Laplace inverse of si minus a inverse x0 plus Laplace inverse of si minus a inverse bus. This Laplace inverse of si minus a inverse is nothing but state transition matrix, and it is represented by e की power at. E power at x0 plus L inverse Laplace inverse phi s bus. So what I am doing, I am replacing this L inverse si minus a inverse by phi t. L inverse si minus a inverse is equal to phi t. So this will give e power at x0 plus L inverse phi s bus. L inverse phi s bus is as it is Laplace, because this is the multiplication of phi s b into s. So we cannot write here this in time domain. We can write here only e power at. Laplace inverse si minus a inverse is nothing but phi t is equal to e power at. So I am writing here e power at x0 plus n inverse phi s bus. E power at is nothing but phi t x0 plus Laplace inverse phi s bus. So this is nothing but this is the force response of the system. Now, so I have discussed the homogeneous solution and non-homogeneous solution of the state space equation. So in the non-homogeneous equation, I have considered input. In homogeneous equation, in homogeneous solution, I have not considered input, or we have considered ut is equal to 0. Now coming to the next topic, controllability and observability of the system. How will you check the controllability and observability of the system? So basically the concept of controllability and observability was introduced by Kalman, and if the system state transfer from any initial state to any desired state in a specified time by a control unit UT, then we can check the controllability and observability of the system. Basically, if transition from transfer from an initial state to any other desired state in a specified finite time is controlled by the state controlled by the input, then it is then we can check the controllability of the system. And if it is defined by the state by xt, then we can check the observability of the system. So the system is said to be controllable if every state variable of the process can be controlled to reach the certain objective in finite time by some unconstrained control unit UT. So if any one of the state variable is independent of the control unit or input UT, there would be no way of driving this particular state variable to a desired state in finite time by means of the control effort. So if there is no connection between a certain state and input, then the state is not controllable, and if there is a connection is established in between these nodes, then we can say this system is controllable. So for this we can use the formula given by the Kalmans. If the state equation is this, the system is represented by this x dot t is equal to axt plus but. It is completely state controllable if and only if the rank of the recombined matrix is n. So what is the condition? This is the combined matrix Q is equal to B AB up to a ki power n minus 1 B. So determinant of Q matrix should be non-zero. If it is 0, then system is not controllable. It is not necessary we have to match the matrix rank of the combined matrix. So it should be equal to the n. Now let us take an example for checking the controllability of the system. So let us take an example. X1 dot x2 dot is given in this equation. So value of, we have to identify the value of A and B. So value of A is 3024, B is 01. So what should be the combined matrix? Combined matrix will be equal to B into B and AB. So B is already known to us. What will be the value of AB? We have to multiply the two matrices. A is 2 cross 2 matrix. This is B is 01. So after multiplying this, I will get here 04. So what will be the combined matrix? Combined matrix S will be equal to BAB, which will give 0104. So it is clear number of non-zero rows will give the information about the rank of the matrix. So here the one row is 0. So you can say the rank of this matrix is not equal to 2. Or you can see here this is singular matrix. So this system is not controllable. So the primary requirement for checking the controllability of the system, the rank of the combined system should be equal to n. So here we want the rank should be equal to 2. Rank, if I am finding this the rank of the combined matrix, the rank of the combined matrix is 1. So this system is not controllable. Now coming to the observability, a system is completely observable if every state variable of the system affects some of the outputs. The system is called observable. So if any state of the system cannot be observed from measurements, it is called unobservable. So it is clear in this state x2 is called unobservable matrix. So in this figure it is clear that x2 is called unobservable. So how will check the how I will check the observability of this system? This is not the controllability, this is observability. basically. So I will check from this if the system, this is also given by the Kalmans. So for checking the observability, we have to make the combined matrix. For getting the combined matrix, we will use this output equation, y is equal to cxt plus dut. I will take I can write the combined matrix ct 80 power 80 ct up to 80 n minus 1 ct. So what will be the, when the system will be observable, if the rank of the combined matrix is n. Similarly, as we have find the rank of the combined matrix in case of controllability, similarly we can find the rank of the combined matrix in case of observability. So we have to find the number of non-zero rows, or you can find the determinant of the, for checking the controllability or observability, you have to find the determinant of the combined matrix. Now, eigenvalues and eigenvectors, the roots of this characteristic equation are often referred to as the eigenvalues of the matrix A. Now, what is the characteristic equation? Characteristic equation is Si minus A is equal to 0. So here I am considering that I am not interested here for the, especially for the state space model. So I can consider characteristic equation as lambda I minus A is equal to 0. So eigenvectors are useful in modern control methods, one of the which is similarity transformation. So for finding the values or eigenvalues and eigenvectors, what will I do? I will put this, will give the information about the eigenvectors and eigenvalues. So how will you find this eigenvector and eigenvalue? This is very simple. We have to find the we have to write the characteristic equation. What will be the characteristic? I am considering in this I am finding this eigenvalue and an eigenvector for state space model. So this is the state equation in which A, B and C is given to us. So what will be the value of characteristic equation? Mod of Si minus A. Mod of Si minus A will give, Si means S minus S, sorry, S0 0 S, Si minus A. So I will write here 0 1 S plus 1. So this will give S square minus 1 is equal to 0. So this will give mod of Si minus 1 as Si minus A is equal to S square minus 1. So for getting the eigenvalues, we will consider this lambda I minus A is equal to 0. So I am considering here lambda 1 and lambda 2. If I am considering lambda 1 is equal to 1, so if I consider here, what will be the value of S square minus 1 is equal to 0? This will give S is equal to plus minus 1. So one value of S, if I consider here lambda, so lambda 1 will be equal to 1 and lambda 2 is equal to minus 1. By putting these values in this equation, if I replace this by lambda, you can, for avoiding the confusion, so I can get the value of P1 and P2. These are eigenvectors. Eigenvectors will be equal to P11, P21 and P2 is equal to P12 and P22. So by using this lambda 1 is equal to 1, I will get this. So from where I will get this? By putting lambda 1 is equal to 1 in this equation, I will get like this. After solving this equation, I can get the value of P11 and P2, P11 and P21. Similarly, I can get the value of P12 and P22 by putting lambda T2 is equal to minus 1 in characteristic equation. So after getting this, I can replace this, I can get the value of P11 and P21 and P12 and P22. So this will give the information about the eigenvectors for corresponding values of lambda 1 is equal to 1 and lambda 2 is equal to minus 1. So this is all about the state transition matrix, controllability and observability of the system, homogeneous and non-homogeneous solution of the state equations, and brief information about the eigenvalues and eigenvectors. So thank you. This is all.